Hey, all right. Good morning, folks. Hello. Let me know if you can hear my audio. Okay, everything's coming through. It's only the second time streaming in a while, so just want to make sure things are working out. All right, so super excited about the stream today. It's going to be a lot of fun. So last week we designed a tracker, a GPS, a kind of a low energy GPS tracker around Meadow that had also a BMI 270 accelerometer slash IMU, inertial movement unit, as well as a BME 688, which does temperature, pressure, humidity, and air quality index, and also has solar power, battery charging, and a few other goodies. So let me show you. This was our PCB that we designed, and today we're going to turn this into. Sorry, this is the schematic design or schematic capture. Today we're actually going to turn this into a PCB, and let me show you what I've done or what we're gonna create. Let me see if I can get my iPad to work here. Unfortunately, it's not showing up. Trusted it. Well, all right. Well, let me just show you. I'll use my webcam. Not super efficient, but basically we're going to build something like this. Okay? It's going to have our e-ink display screen. It's going to have GPS antenna, and then it's going to have our battery up top, and then some places for the sensors to poke through. So that's what we're gonna lay out, and I really like layout. So full transparency, layout to me is like Sudoku or other mind puzzles. I really just it's like painting or something else like that. I really enjoy it. It's very meditative. So I'm excited to lay this out. And yeah, why don't we just get started with it? Enough preamble. Okay, so we're here. Let's go to convert schematic to PCB. Yeah, I guess we should check our nets. Okay, so this was our shared 5 volt reg V regulated voltage output. That's fine. So we're good there. Convert, keep going. Okay, so we're going to do some things right out the gate to make this a little more reasonable. So millimeter units, everything I design anymore is in millimeters. Grid size 1 meter or 1 millimeter. Snap size 0.5 millimeter, and alt snap is going to be 1/10 of a millimeter. And then we need to get rid of these terrible lines. So much better. Let's get rid of that outline, and let's also set up our controlled impedance rules. So recall that we have this with our stack up. We need 90 ohm impedance, controlled impedance for our USB, and then 50 ohm impedance for our GPS stack up. So let me just drag this off to the side so I can remember this. So we're going to go design rule, and we're going to fix these. So what happens is there's a little bug. It's a floating point math bug in Easy EDA when you switch from imperial units to metric units, you wind up with some kind of wonky things here. So we're going to get rid of these. We're going to fix those. Like this via drill diameter should be 0.3 and it's 0.05. Okay, so those are good, and we're going to add a new one, and we're going to add this. This is going to call 90 ohm, and this is going to be for the USB. And recall that the inner layer, it's actually going to be on the outer layer. So I'm just going to put the outer layer one in. It's 0.19 millimeter width and 0.11 spacing. So that's 0.11 spacing, and then these are just going to stay the same. And then we got one more, which is our 50 ohm, and this will be for the GPS GNSS antenna. And we're going to put it in the outer layer again because that's where we're going to route this actually. And there's no clearance, crazy clearance on that, so I'm just going to put the same thing as there, and then 0.3. All right, and cool. So now we're going to assign these two rules to the appropriate nets. So the USB gets the 90 ohm, so we apply that one, and then the antenna, whichever one that is, it looks like it's not named in here, so we're gonna go save this and go back to this net here on the antenna. Actually, it is named. It's GNSS ANTT or ANT. So design rule GNSS antenna. There we go. And that is going to get the 50 ohm. And we're going to apply that. Cool. So USB is at 90 ohm. The antenna is at 50 ohm. And we're good to go. So that's fantastic. So we're going to get rid of this. Okay. And the next thing I want to do, and this is really just, I don't love the colors by default on oh, I've got to do a couple of things. First, I've actually got to turn this into a 4-layer board. So recall that this is that we chose to stack up from JLC PCB last week. So if we go capabilities and we go controlled impedance PCB layers stack up, and this is the one we're using a 4-layer JLC 7628. So we actually need to set this to 4 layers. So we're going to go layer manager, 4 layers, and we're going to fix some of these colors. I hate the colors that it comes with. So I'm going to let me find another 4-layer board that I have where I can grab some colors. I think this one probably has it. Let's see. Some better colors. I'm going to use the Wilderness Labs colors. There we go. So we're going to do tools, layer manager. So the top one, copy that. Go back, tools, layer manager. Put that in, save that. Settings, save. And let's do this one. We got one more layer to grab the color on. Sweet. Oops. Okay, sweet. Much better. I like this color scheme. Much, much better. All right, so we're going to do some rough layout here. First thing we're going to do is let's drag this off to the side. That's going to go above everything. I'm going to do the battery up top, and then my GPS module is going to go over to the right along with this antenna. And then I'm going to do, so this is my USB, and I'm going to do that at the bottom. You do bottom or side. I've got some other stuff coming out on this side. That's where the antenna is going to be. And then I need to do my core compute module. And so the main thing here is that we're going to have USB lines going from here to here, and they're going to be differential pairs, and differential pairs are two side-by-side lines. So you can see here they are. So this is a differential pair. They're basically just two side-by-side lines, and they typically you want them to be the same length, and there's some design rules around them, but nothing that we're really going to run into today. But that's for the USB. And what else? I want to get some bolts in here. I didn't add them to the design, so I should probably could add them to design, or I'm just gonna grab them from here. So these are looks like 2.1 millimeter holes. So these are gonna be for a 2 millimeter screw. So I'm gonna put one here just to start, and then let me grab one of these. Let me grab an outline corner too. Like all good designers and developers, it's a lot of copy paste, right? And I'll make sure to open source all this. I'll put it in a repo. All right, we already know what these are, so we're gonna get rid of their prefixes. There's one thing though that I need to fix, which is this solar battery power. I forgot to put a pin 1 marking on the footprint. So you see this one has a pin 1 marking. This one has a pin 1 marking. This one has a pin 1 marking. And our solar power thing does not have a pin 1 marking. So let's fix that. So let's first find our project. It's this one. So let's find our PCB. Oh, yeah, that's not it. Actually, that's just a breakout board for it. It's the core compute add-on module. So pin 1 is down here on the bottom. So we're going to go to our library, and I'm going to find solar, and it's going to be, that's the one. Let's grab our footprint of it, edit, and let me grab another footprint where I can just copy. I want to be consistent, so I'm going to say add-on. I think I got a bunch of add-ons here. Ethernet, power reset. There we go. Let's do this one, and let's grab this pin 1 marking. Okay. Ooh, it didn't add. Didn't copy like I thought it would. All right. Let's try to copy and paste. All right, put it right there. Cool. There's our pin 1. And if I go here and we're going to update this. Update, save. Okay, and now this one, if we do Alt I, it should come in with the dot. No, we're good. Okay, there it is. There's the dot. Cool. That's good. Okay, back to layout. So this is where our USB comes in. I'm gonna just gonna be on the bottom. I'm gonna just drag it kind of over. This is close enough. I mean, it's not. That's enough clearance from there. It looks like. I could simplify this routing a little bit if I turn this sideways, and then I turn the cord compute module sideways and just put the USB right next to each other. I want to do something real fast. Let's hide some power and ground, our main power and ground for now. Oh, look at that! Look at see the difference in quantity of rat lines, which are rat lines are unrouted nets. So huge difference when we turn those off. Anyway, I'm gonna put this here, boop, like that, and then this one, I'm gonna put it here-ish with a little bit of clearance. This is where the antenna is gonna be, so it's gonna be in the bottom. Okay, and now we're going to put this off to the side for now. Solar is going to come in. I want to put all of my sans, my antenna, all of my openings, all of my connections and stuff are going to be in the bottom. So this is our solar power. So put that on the bottom, and then I want to, let's see, we're gonna have we got our two sensors. We got our inertial movement accelerometer, and then we've got our BME 688. And I'm gonna put, I want this accelerometer kind of in the center-ish. It doesn't really matter on this, but if you were like doing a handheld thing or whatever, it would kind of be more important. Okay, solar battery power. I think, let's see, let's look at so solar in is on the bottom, and then the voltage out is on the top. So I'll leave it like this because this is where the solar comes in. And then I'll put this. So we're just doing rough layout right now, just to kind of get the general, just to kind of see where things are going to fit, and then we can tweak them as we get further in. But I just kind of want to do have a rough idea of where things are going to be. And that's going to be antenna and it's going to roll up right into there. See, one of these is, ooh, these are backwards. Look at that. Pretty sure that is absolutely not correct. So I need to fix that. Let's get rid of this prefix because we know what that is. So let's go to this thing. Let's go to our deal 603 library. Boop. All right, signal and ground. This is 2, 2, 1. Okay, so I think what we need is that this is going to be 1, and this is going to be 2. And that will match the footprint. more appropriately. There we go. Update footprint. Boop. Save. Let's go back here. Let's update from library. Save this. And then come here, and then Alt-I to update. Apply our changes, and now this should be better. Great. That's much better. Okay. Put this somewhere in the middle-ish. Battery's going to be up there. And I want a kind of hole for this. We're going to put it right here for now. There's going to be, we'll put a hole in the PCB. I mean, sorry, in the enclosure here, so that this can get exposed a bit. Or maybe we'll do on the sides. We'll do some baffling or something. Okay, so that's more or less about what I want to do, and then this is gonna kind of be, I want this kind of on the bottom. I just want it below the battery because the battery's going to be kind of tall. So if we look at the Klima board, you can see that's the battery there, you know, and it's kind of tall and above. So yeah, more or less there. Cool. This is going to be tricky with this USB line, so let me put this off to the side. We may want to drag this up a bit. Yeah, somewhere like that. It's got these holes. I wonder if those are going to drill through. I bet they will. We don't actually want these holes. Is that a hole? Multi-layer pad, yeah. Let me see if I can, oops. All right, so I am going to edit this footprint to not have those holes. So to do that, we need to go grab the part. Here it is. And there's that, here's the footprint. Adafruit 2.13 e-ink 497. I wish I could just hit click edit, but I actually have to search for the footprint. So let's see, Adafruit 2.13 e-ink 4197, and then click footprint. User contributed. Okay. That looks like the one. And we're going to do clone it. And we're going to say no holes. So now it'll be in my workspace. I'll do edit and get rid of these holes. And I'm getting rid of the bolt holes because it's going to be soldered down to with that header, so they're not really necessary. In fact, what I can do, grid style dot, I could put little like crosses in here to show where the bolt holes would go, but I don't even think I need that, honestly. I'm just gonna do this. Doop, 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 doop. Save. Cool. Back to the library. Symbol. Here we go. And I'm going to edit this so I can change the footprint to the no holes. Search in my workspace. There we go. All right, let's update. Save. Okay, now we're going to update this. Cool, now there's no holes. fantastic. It won't be blasting through stuff. So this more or less looks like what I want to build. Let's grab these and put them make a little outline. And everything, I like to do everything on even or I really like to do everything on 5mm grids, which is compatible with some of the old, with some other stuff, some other boards and whatnot, where you can kind of make a quick prototyping, stick them in the grid. So let's go to our document layer and let's go measure these and see 72mm. So we either need to add 3 or lose 2mm, and I think we can actually, looks like we can probably lose 2mm without issue. So boop, 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 boop. That's 2, right? Looks like 2. 70mm there, sweet. And let's do from here to here, 96. So we want to do preferably 95 if we can. I don't know if we actually have the room here. We may, let's see. Okay. Okay, board outline. Let's close this up real fast. This is gonna be 0. Sorry, it's in like imperial, right? 0.254, which is a tenth of a inch or whatever. We're just gonna do 0.20 for these lines, and now they'll all be 20 from here on out until I change that. Alright, this is going to be, I think, all the way basically to the edge of the board. Cool. And this is going to loop out to there. So just something, a little design consideration I'm thinking about. Okay, let's take a quick look at this. Let's see if we got, let's see what the 3D, and we don't have models, 3D models of most of this stuff. You'd see the little jelly bean bits are there. Oh, and the 2 sensors are there. But that, I think, is more or less what we're looking for. I could swap, I could put this over on the right and this over on the left, which I think I might do. I think we're done with these. Okay. So let's drag this over. this. I actually want to put this hanging off because of the enclosure. Looks like it's going to be, that's about 2 millimeters off. I'd love to get it closer, but I don't want it. I don't really want this on the edge. I mean, these are just ground bits, so they're probably okay. But the more I can hang it off, the better. So that gets me 2.5 millimeters off, which gives me, you know, 0.5 millimeter of spacing and then 2 millimeters of wall thickness to get that somewhat flush. So that should be good, and this spacing is probably fine. Okay, cool. Somehow my layers got, or all my rat lines got shown again. So let's get rid of some of these. Okay, cool. So this is, I think that's the positive one. It's going to go over there. Okay, so let's start grouping our components up a bit. This is my BME 688. So I can put that, maybe I'll put that over here. And it's either that or I'll put it over here. I'm not real sure. This is my accelerometer. So kind of dead center in this thing. It's going to be right there, but it's also going to conflict. It's going to conflict with my USB lines. So maybe I'll put it here or even put it up here. We don't need a prefix on that. It's just taking up space. Okay. I'm going to do a couple other things. I want to actually know the center of this. So we're going to draw some lines, but first, oops, we're going to do some more dimensions. So this is overall board size, 75. By 100. Nice. Okay, so this, we're going to do a line, and it's going to be, I'm just going to put it there, and now we want it, we're going to set the X 50 and 50. Hey, it's already right dead center. Perfect. Let's do another one. Get close. Alright, so this, so it's going to be 35.5. Right? No. What's half of 75? 37. Calculator for the win. 75 divided by 2. 37.5. So 37.5. 37.5. Perfect. So that's dead center. And it's just nice because then I kind of have an idea where it's at. I got 2 turntables and a microphone. Alright, let's do some more measuring here. So this, center of this, 10 over. So we'll need that when we do our layout. And then this USB, same thing. Center of USB, 17 over. All right. That's a prime number, isn't it? Okay, now, boo, boo, boo. Okay, so, that's a funny place for that prefix. Wait, U7, that's this one. See, display prefix, no, I don't need that. We don't need that, because we know, it's obvious what that part is, right? Okay, now we've got this stuff more or less where we want them. We need to start grouping all the components together. Each, you know, like the sensor has some constituent components, etc. So let's go find them. So let's start with that BME 688. So I'm gonna select its components, and then there they are. All right. And we may rotate this around again depending on the I2C lines, how they come out. But for now, we're just gonna kind of get our components roughly where we want. I wish I could set the default font to be not this giant thing, but boop. Okay, so these two caps got to go next to their 3-volt 3 lines. So let me see, C1, C3. Those C3 is on line 6 or on pin 6, which is 1, 2, 3, 4, 5, 6. Did I say C3? I think so. C3. C3 is going to be pin 6. And boop. Okay. And then the other one goes to the other one, pin 8, C1. So that's down here. Okay, C3. R8. Some room for those I2C lines. It's going to be the end of the I2C, so we may put this over here and route it, zoop, and then route those up. But we'll see, because we don't know. We might rotate this whole thing. Okay, so those are together where they need to be. Let's get the antenna stuff together. And let's get these first off of the GPS module. R9, R7, 222. So these are going to loop around and go through there. We'll figure out exactly where those are in a bit. Okay. And we'll group these up and then we'll massage this screen around a bit after we do our USB routing. So let's grab all the parts for the BMI 270. Let's get those where they should go approximately. Boop. Okay. And this is a good time to get our I2C right too, our directional thing, just to make it easy on routing. So data and clock. Data's on the right. data and clock. So these could just go straight up like that, or they could go on the outside and loop around. We'll figure that out. Actually, we'll figure that after we do the USB. So for now, I'm just going to get these things kind of in their location. All right, two caps, C2, C4. C4 is on 5. So 2, 3, 4, 5. So it's going to go up here-ish. And C2 is on pin 8. Pin 8, that one. How's everyone doing today, by the way? It's a quiet chat room. It's never this quiet. Okay. Sweet. So this is more or less, I'll call this good for now. Those are all grouped together. Let's get a few more things down here. Let's do our, let's go back to our antenna. So we forgot to do that. This. Okay, this should be fun. Each one of these just goes right next to their thing. If I recall. Wait, what's that? All right. So where's this cap? What's this cap doing? That's from antenna power out to ground. So I think we can just put that right next to it. So this is going to, that goes to power. Boop, boop, boop. Okay, so I'm going to basically route this out, and then it's going to turn and then go to there. So let's do this. Boop, boop, boop. And yeah, it's more or less going to be right. Maybe I can move this up a bit. Okay, good enough. We can massage that a little later. And now we've got just a few more jelly bean components. So our I2C pull-ups can be R1 and R2. We're going to put those close to the I2C lines. So that one is on top, that one is on bottom. Let's see. I think we might do, that's the bottom one. Might do like this. So our I squared C pull-ups. And those might be in the way of the USB. So now that I think about it, maybe I'll pull them over. So these USB lines are going to come up, and then go right over here, and then we're going to drive the I squared C, I think, straight up and under. So let me do this. Let me just put them up here for now. Okay. Cool. And then we've got these final little blinkies. So add a little blinky, little LED to the core compute module. And we can put these just wherever, really. And I think maybe, I know for whatever reason, I feel like I want them over here with the others, with the BME and the GPS. But yeah, I don't know why. But I'm going to do that. So put this over here, and we'll figure that out. Move them around later. Okay. Cool. We got a pretty good layout now. Do real quick T elimination break. So I'll be right. Okay, I am back. Sweet. So we're about 45 minutes into this. We've got basic layout done. Now it's time to do the routing. So first thing we need to do is the high value signals first. The ones that are require like the most important considerations. High-speed signals, etc. So the first thing that I'm going to do is the USB signals. And this should be really interesting because I love EasyEDA. But with that said, this is the absolute worst feature it has. So this differential pair routing, it is terrible. All right, so we're going to Just gonna come this way. Boop. And then, come on, you can do it, easy EDA. And it cannot. Look at that. What is this nonsense? So dumb. Okay, so I'm gonna do. I'm just gonna get it in here. Get it right, kind of in the center, as much center as I can. And then, all right, we're just gonna end it there. And now I'm going to oh. Why did it do that? And I'm going to do a manual wiring from here on out. Come on. Come on, what are you doing? What are you doing, Easy EDI? Boy, alright. 0.190. So I have to do kind of, so this is at 2, so I have to do this. 0.19. Now I can hopefully, see, doesn't it? It's violating the rule of it being next to that. So, boy, there we go. That did it. Wire, come on, wire. All right, that will be good. Now, if we just don't touch those, it should be fine. It's the worst part of Easy EDA. That was less painful than it normally is, actually. Okay, great. USB is done. Now let's do SPI and I²C. So I'm going to do I²C first, and I'm going to run them down in the third, in the inner layer. So let's talk about layers a little bit. So we have 4 layers on this board. Top layer is going to be signals, and then power plane. Next layer is going to be signal and ground plane, and we want ground plane because we have that controlled impedance. So the controlled impedance only works if you have a ground plane on the other side of those signals that need controlled impedance, in this case the USB and the antenna. So it's going to be power ground, or even maybe power ground, ground power, in terms of the stack up. So I'm going to run the I²C in an inner layer. So to break those out, we're going to put a via there and a via there. Drag the vias off, top wire, and this has got to go back to 0.2 because it remembered our last thing. Boop. Okay, I²C. And now, because I've done this, I can run them. I can route this way, left, right, or I can swap these and then route right, left. And I think I want to get this so that they align more or less. Oh, and I've got this, now that I've got the USB down, I can move this around too. So I want this right in the center, I think, or maybe on the left. I was considering maybe someday even adding buttons to this, but I think for right now, let's just put it in the center. And I want it kind of down, just, I don't know, just a design thing. I kind of want it downish. Oi, downish. All right, so there we go. Those are clear. Cool. Now, let's take all this, and I am going to rotate all this so that the I²C lines are going to run right straight through and across. Okay. Boop, boop. We're going to move this down because remember, I want to get this kind of in close to the center as I can, the accelerometer. In fact, let me see. I could move the screen up, and then I could put it right here. It's not a bad idea, right? Move the screen up, like to here. Move the accelerometer down. That's the center. It's not going to make it to the center, but I could make it pretty close, right? And this would be clear of those USB. And I don't think the screen... So the screen does have a charge pump to update it. So there's some crazy electric stuff that may affect that IMU. Now that I'm thinking about it, because the IMU depends on the magnetic lines of the Earth. And I don't really want to interfere with it, but I don't know where that charge pump is. I think it'll be fine, honestly. Yeah. All right, I think it's going to be fine. So I squared C, this goes here. Let's move this up a bit. And then this one, dope, stop, collaborate, and listen. Okay, so we're going to lock this. I don't want to grab there. Come on, no, this, there we go. All right, and this is that. This is for that. This is for that. This is for that. Okay. Okay. So data and clock. Data's on the bottom. Datter. That's how the Australians would say it. That's how Craig Dunn, some of you folks probably know, would say datter. Okay. Still kind of close to that USB line because I gotta put a via here. Somewhere I gotta put a via. Because I can move these up. And put the via here. That's pretty close to that. It's pretty close to that USB. I don't really want that. All right. I'm going back to what I had before. I'm moving the screen down, and I'm moving the accelerometer up. Oh, come on. All right, let's see if I can select just those. Oh, killing me is the EDA. Let's try this again. All right, moving those up, moving this down. All right, cool. Much better. Okay. And now put a via there and a via there. Okay. And now let's get these, because that's how we're going to route them. And it's going to skedaddle over here, and it looks like the orientation is good. So we can lay that out in a sec. Okay, let's clean this up a bit. Lines are going to come up, come through here, doop doop. So I am going to push these together a bit. Go. Okay, that looks good because these are going to route right through here like that. We're going to put in the layer 2, or it's really layer 3, it's inner 2. And these are going to route up right through here. Okay. So these are routed more or less. Let's finish this routing. Comes up, hits those pull up resistors, and then from here it needs to continue on over to here, and I'm going to route them down again. And I don't really want stubs, so I could route on the same layer. I could continue on and, you know, route it on down and over like that, but then this would be a stub between here, which is kind of like a dead end, and that will cause the signal to kind of have like a ringing effect. So I don't want that. So ideally we're going to break them back out. Oh boy, if I move that, I have to delete those. They're attached to that line. So there's a little bit of a trick in what that if you hit a via and then you put it on something, then it'll get that net, but then it also attaches to that line, so that's kind of problematic. So let's see if we can put these, let's see if we can fit these vias in here. I think we can. Clock and datter. All right. Okay. And then back to inner 2. Well, let's put some, oops, put some vias. Those are probably too close, but we'll see. Okay. We can massage this routing later. Mostly just need to get it, you know, routed for now. Okay, so I squared C is routed. Okay, that looks pretty good. And now we want to do SPI. We should also route this antenna, but it's pretty clear on its own, so I can do that there's no real considerations that I have to do with the other layout, so I can do that later. So let's route SPI, and that's going to be to the, I'm going to lock this down, lock down this so I don't drag it around, and same with this and this. Okay. So SPI drives this Adafruit e-paper display. So it's going to be this copy and SIPO. Huh, look at that. It's going to drive right to it. Boop. That's easy. So that's controller out, peripheral in, and that's actually the data line. So that's kind of the important one. I don't actually know why it has back in. Oh, I know, because of the SD card, which we won't even use. But there we go, and we're gonna let's put this. Got some options here, so I can do a couple things. I can put this on the bottom, and basically, cross everything. It's totally fine. Another option I have is to pull these out and put it on 2 and route it around, which I want to do just because this is gonna give me more room on the bottom for some other stuff, so like this VBAT power and whatnot. So that I feel pretty good about that. Okay, sweet. So that's routed. Those two are routed. Miso Mozi, Sipo Soapy, Sipo Kopi, Kipo Kopi. Trey, good day to you too as well. Okay. So I2C and SPI are routed. So those are those high value signals, as well as the USB, right? So USBs in SPI, I2C. So that's the main bulk of like the high value signals. Actually, the only thing left that's high value is the high consideration is the antenna, and we can do that stuff in the very end, just because of where it sits. So let's just start doing the kind of just the other stuff. Oops. All right. So the reset and busy. EPAP. Toop. EPAP. Data command, we gotta get that one over there. Oh, that's kind of tricky. We're running up and around, but I think I'm gonna slide it through some stuff. Kind of silly. All right, let's do this. We're gonna drive this EPAP data command. Boop 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 boop. Right there. This is gonna be fun. Let's get this out of the way. And top. Boop. All right, 2, like that, like so. There we go, very nice. And I'm gonna do the same thing to this, actually. So we're gonna do a little cleanup. There we go. That's cleaner, right? Okay. ECS. I don't remember what that. Oh, chip select. But is that the display chip select? The e-paper. Yeah, it is. That's the e-paper chip select. Oh, and I forgot serial clock. It's SPI clock. So that's actually it's super important. High value, because between these two, that's really what drives the display. Okay. Clock. Chip select. EPAP chip select. All right. All right. I'm going to route this around. Boop. Very nice. Very nice. What else do we have in here? Ground, power, enable. That's not connected. Okay. Oh, you know what else we need that's reasonably high importance is the serial data lines to the GPS. So I forgot about those. So this one's, let's see. So we got this one, COM, boop. And then we got the other one, COM4, RX. Okay. So I think I'm going to run those on the bottom. That way I don't have to cross these I2C lines that are... Actually, this one I can run at the top. I think I'm running them both on the bottom. Okay, and we're going to drag this all the way across. So we may move these. Ooh, you know what else I can do? I could route these I2C lines around this side of them, and then I could put them on the inner two with all those other lines. I think I kind of like that, actually. Let's do that. Boop. Boop. Let's move these down. Let's move this over. Sweet. Now let's move these. Boo 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 boo. Little airwolf. Okay, now I gotta swap these, I'm pretty sure. And by the way, it's no problem putting stuff underneath this e-paper display. It's gonna kind of sit up above things quite a bit, I think. Okay. So 2. I want it this way. Okay. I like that. That's cleaner. Ooh, cleaner. Doop, doop, doop. Doop, doop, doop. All right, looks good. Cool. What else do we got here? Solar voltage in UI 79. Where's that going? Looks like it's going to the blinky. And VBAT. F7 reset. And 5 volt. 5 volt comes from the solar power. We're going to run that probably on the bottom. It's going to be a big fat trace. Why don't we run our reset line? Going to run it right through here, I'm pretty sure. There we go. And VBAT, battery power. It's looking pretty good so far. Solar in. You know, we're largely routed. Not bad. Let's route out this stuff now, and also we'll kind of tweak our layout a bit. I got lots of room. Boop. I'm going to move this down. Bottom right. All right. That looks good. What's that? Time pulse. Time pulse. Probably never ever going to use that. And GNS not to reset. Solar voltage, VBAT. Okay. Saving. Let's lay some copper. Okay, we're gonna lay big fat copper area for this 6 volt that comes in. 6 volt solar. Boop. Nice, big fat copper area. Make a little couple small tweaks to it. Don't need those extras. Pull this over a bit. Nice. Looks good. 6 volts coming in hot, coming in strong. Cool. And then our battery line. So I'm going to run this up to the battery first and then over. So we're going to do VBAT. This is going to be a big fat 1 millimeter, 1.5. There we go. And then 5 volt. Where does that run to? I don't remember. Let's go look. 5 volt drives our charger, but that's all internal to it. 5 volt. The USB stuff. That's right, because this can power the. This can charge the battery if solar's not hooked up. So we want 5 volt from here to there. It's gonna be big fat 5 volts. Boop. Okay, those are nice and connected. And it's gonna come to here. Maybe I will. I know what I'm gonna do. It's gonna be cool. It's gonna be cool. We're gonna lay a big fat copper pad around it. Okay, and then we're gonna put some vias. Bunch of vias. Vias are free. Evidently. Same thing over here. Cool. Come on. Keeps wanting to select that screen or whatever that's above it. You know, in KiCad, let me see, if I select, you hold down like Alt or something in KiCad when you're selecting, and then it gives you a stack up of things to select. I'm trying all the buttons. Doesn't look like it has that in EasyEDA. You know, kind of a nice feature. But alas and alack, I don't think I like that. Let's keep it down. Alas and alack. All right. So we're going to tie those 5 volts together with a big fat thing. Solar voltage. Let's route that too. Boop. Boop. I gotta resize our default lines. There we go. Solar voltage. Oh, what's going on? There we go. Oops, if we're on the right. Cool. Okay, bottom. I'm gonna put a big fat plane. I want to do actually. So we're on the bottom. Do a big fat power plane here. Boop, boop. Boop, boop. 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 Nice. Just because I'm OCD, we're gonna make that the same. I'm not actually OCD, but I am when I do layout. It's kind of fun to be OCD when you're doing layout. Okay, there's a nice big plane to grab on there. We're going to do the same thing here. Yeah, nice. And now we're going to do a big fat, see on the bottom, we're going to do a big fat line to it. Nice. Let's do 2. Why not? Why not? Look at that. That's good. All the power. And then we got to do the same thing for battery. I'm also going to send the battery along the bottom. So let's start with the top. Let's get rid of this. We're going to do VBAT. Okay. Key. Those are all wrong. I scored C. Let's try this again. Okay. And now let's go to the bottom. Make another nice copper pour here. Gonna run that here. Gonna run that. Boop. And then we've got to run it one more place and run it over where? Where are we going to run it? No, it's got to go somewhere else. V-bus. It's got to go here. And that doesn't have to be a big fat line. But that's just, I think this is just for the RTC, real-time clock, just to keep it alive. Do this. Top, bottom, wire. What's going on? What's going on? Why is it not letting me wire anything? I think this, we're going to do 0.3 on this one. So we need a little thing. And then 2, bottom. Why is it not letting me track this? Did I get that wrong? Is that the VBAT? Oh, that's why. I put it on ground. That's why. All right, let's turn this around. Boop. There we go. And now, should run to there, no problem. Cool. And what has happened with this thing? Why is this way over there? Somehow it got onto the top, on the bottom layer. All right, fixed. What else do we have? Boot lines, F7 boot button, VBus. I should have routed that a while ago. Oops. Oops. All right, VBus. And then boot. Let's talk about it. That's Canadian. I'm fluent in Canadian, eh? Line. Where we're gonna snake this through. All right, that's the thing. VBus. Boop. Boop. Oh, that's not gonna work, is it? But you know what will work is if we put this over here. Wait, gotta get that 45. There we go. Put this over here. And then, boop. Very nice. Okay, and then this one. Cool. Accelerometer interrupt. Gonna run that. So I think I know what I'm gonna do here. Oh, that was silly. Why did it do that? Accelerometer interrupt. Yeah, should be fine. Oh, wait, stop doing that. Stop doing that. Very good. What else? This LED, I'm gonna route that. Route that underneath too. So let's do this. Okay. Oh, look at that. I missed this 5 volt here. So let's fix that. If I can select this. Looks like this is, I did this 5 volt first, so it's getting precedence. See this VBAT, but there's lots of room there for, I mean, there's lots of spots for the 5 volts, so I'm going to move it over. There's lots of connections here. There's less connections for that VBAT. There we go. Although I guess it didn't really make a difference. It's not like it actually connected it. So maybe I'll just go back to that. Okay. Cool. Now let's go to the bottom. Let's extend this one over. What else do we have to route? We still have this antenna, the GPS stuff, and then we're going to have a bunch of power and ground, of course. But I think otherwise we're basically routed. I'm gonna fix that. It's locked. It's alright. I don't feel like unlocking it. It's upright. That's all that matters. Looks pretty good, yeah? I don't know why I want this like that. Just a little better. Oh, look at that though. The hole. That's not going to work. I just don't love this. This is a acid trap. That's when they etch it with acid, could get a little there. The acid can get trapped and then it eats out like kind of around. I don't know if that's really a problem anymore with modern lithographic etching on these. I think they use light now rather than acid on the copper. This is looking pretty good though. Let's take a quick look. Let's see. Black. Yeah, that looks pretty good, right? So there'll be a nice e-ink display screen here, the big fat battery up there, USB over here, solar input over there, and then our antenna will come out to the side and then go up. Yeah, looks pretty good. Okay, let's go back to it. So let's route this stuff. Okay, so the first thing, I need to route this antenna. This is going to be a little tricky. So I need to do, let's move this out of the way. This should have picked up, so this didn't do it. It should have picked up the antenna rule, which is 90 ohm. So that's, or 50 ohm rather, 50 ohm. So it should have been 0.29 GNSS antenna. I don't know why it didn't do that. It should have gone to 0.29. Usually it does that. So I think that's might be a regression. All right, so there's our 0.29. The other thing that we need to do here is I want to make this round rather than straight, and I'm not sure how to do that in Easy EDA or if it's possible. So let's look it up. Easy EDA round corners. Round corners. That's on the board outline. We don't want that rounded corners. I don't want that. I don't want the PCB round traces. Round trace corners. That's what we want. Curved Bezier tracks. Bezier, this I don't see any of those as being round. There's their differential pair routing, a terrible feature. Auto router, which is the worst. All right. Whoa. 70s style. Look at that. That's kind of cool. Very organic. Free draw, right hand canvas attributes. Can you not set? Let's see. Tracks can only be straight lines or arcs. Cubic or Bezier. But an arc is all we want, actually. So maybe I will just draw an arc. I think it's arc center, arc endpoints. I think that's what I want. Ooh, whoa, that's not quite how I want it. Let's try it again the other way. Nope. That's not what I want. I wonder if I can just change the... Ooh, look at that. Oops. So that is 2 millimeter radius. That's pretty good. 2929. Supposedly that's 50 ohms. I was looking. It's funny because I was looking at the GNSS 10 board on micro. It's, GNSS 10. GNSS 10, click. I was looking at their layout on this, and look at how fat their trace is, and I think that's because they made a 2-layer board, so the ground plane is like way underneath, and then they stitched it up. You see those little, you see these vias right here. They're stitching up the ground plane to connect it because RF signals like lots of ground around it to eat up stray signals. But this is a 4-layer board, so I think this is actually okay. Let's get this. It's not quite perfect. Let's say center X should be maybe 90.5, and center Y is 35.5. All right, so we're not. Oh, I see, because this GNSS unit is probably on Imperial. That's fine. That's fine. This is fine. Okay, so we're gonna. I'm just gonna go back. Boop. But it should be 5, like on a 5.4. So it'd be 254, I think. Oh, that's not what I wanted. Not the length. See how it's just off? Like kind of comes out a hair. I guess if my radius is too big, so it'd be 2.54. No, whatever. It's good enough. I don't think that's gonna matter. Okay, so this. Let's see if we can get this right. This just needs to touch on there. It needs to pass through. Oh, come on. It needs to pass through it. But I also want to fit this stuff in. So I got that and this. And we're going to move this over. So it's aligned there. And then this. We're going to do that. I think that's going to be pretty good. And all right, boop, 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 boop. So that should be okay. And now we're going to pour some ground all around this. And actually the whole top of the board is going to have a ground plane. No, top of the board is going to have power, actually. So we're going to pour ground around this. So let's get this. Let's get us a thing. All right. Fat ground plane. Nice. Totally unnecessary. I don't know why I like to. I just like to have the nice corners. It doesn't matter on a plane like this. On signals, it's different, but probably just adding headache. Ooh. Yeah, we don't need that. So it's going to cause headache later on. And I want to put, I'm going to protect this area with ground on all layers. Ground over here too. So maybe we do this. Copy. Oop. So we're going to do internal layer 1. So we're going to go here and we're going to name, we're going to put that in 1. Okay, and then we're going to go layer 2. Again, place this, put that one in 2. And then the bottom layer, place, grab, bottom layer. Okay, so if we look through this one, top layer, internal 1, internal 2, bottom layer. Cool. And now we're going to stitch this up. And by stitching it up, I mean we're going to connect all those layers. What is happening? Oh, there we go. Ground. Cool. I'm just going to put a bunch of these. I don't need to be that close together. Nice. Stitch that up pretty good right around so it'll absorb, you know, signals right around it. And then we're going to stitch up this hole. We're going to stitch it up. We're going to stitch up the whole damn thing. There's a tool, EasyEDA has a thing that will place these in an array, but I don't like it. It doesn't work very well. Oops. And these are through holes, so they're stitched up there. See, it was snapping to this midpoint line. So if I turn that off, it'll stop snapping, and then it'll go to that, and then it'll actually hit the grid. This is definitely overkill. Stitching this up. This is more than it needs, but whatever. Vias are free. That's good. Nice. This is just power. Let's see if I can do anything here to optimize this. That's right in line. So this is the important one. I don't want to interrupt that flow. The flow of water. I'm gonna get this just a little bit over here. Nah, it's fine. It's clear. All right, that's good enough. So I feel pretty good about this. I'm gonna put a couple more, just for giggles and poos. It's an absurd amount of. That's an absurd amount of ground vias. Okay, that's good. Now let's do our final couple things. We need to do some. Is that on the top? Oh, it's on the bottom. Okay. So we need to do our copper pours. So we're going to 3-volt 3 on top. So if I show our unrouted 3-volt 3 nets, you'll see that they are everywhere. 3.3 volts. Okay, and I like to pour it outside of I like to put these outlines outside so I can select them, because if they're on the line, then they're difficult to select. Okay, and then we're going to do the inner one, and this is going to be a ground. And again, so there's no ambiguity in selecting them, I just put it outside the last one. Boop. And then inner 2. So ordinarily you would do like power, ground, or if you had high-speed signals on the bottom, you would do power, ground, ground, power, so that the signals had, the next layer was a ground. So looking at this, we have, we could do our I2C signals and our SPI signals are in the plane 2, they're the third one down. So we probably want ground on either side of that. So it would be power, ground, power, ground. But we also don't really need power on every, we don't need 2 power planes. So I could do power, ground, ground, ground. That'd be totally fine. But I do think I am going to do power, ground, power, ground. So 3-volt 3. Just to stitch, you'll see, we're just going to stitch those. We'll just stitch them together. We'll have good ground, and we'll have good power everywhere. Boop. And then finally on the bottom, we're going to do ground. Cool. Sweet. Now the thing that we got to do is we got to stitch these layers together. We got to connect them like we did here, but they don't have to be as connected. They don't have to be as crazy as that. So I'm going to hide this copper area, and I'm going to start doing some vias for power and ground. So we're going to start with ground, and I'm going to do them on every 10 millimeters, every millimeter. All right, so every centimeter. So that is ground. So we're good. Boop. 20 and 10, 30 and 10, and that's going to be in the way of that, right? Yeah. So we're gonna massage that. Oops. Just pull that out of the way. 40 and 10. And again, there's a tool in here. There's a tool to make this easier. There's like, it'll actually put these vias in there for you, but I don't know. I don't love it. I don't love the tool. So boop. There's a bunch of 3.3 volt stuff there. I'm just gonna put this, stitch it here. Actually, I want to do a couple things. I want to get this out of the way, and then I'm gonna put this, there we go. All right, so the ground plane stitch up pretty well. Should throw power in, but I wanna, while we're doing this, I want to route some of these. What happened there? That's not gonna work. Look at that. Via right through that 5 volt. That would be bad. All right. Solar voltage. Let's just bring it down. Oops. Let's bring it down a little further out of the way. Stop doing that. All right. Probably don't need this one because there's a whole bunch of stitching there. Right, in each one of these caps, we want them to have their own ground via. I forget, there's some funkiness that happens on these decoupling caps when they don't have their own ground. They like, it connects them in a some strange way where they think alike or something. don't see any more unrouted grounds. Let's rebuild our copper area. It's a Shift B. Let's refresh our thing. Oh, looks like it's still unrouted someplace. Boo, 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 boo. Boo, 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 boo. Looks like all those have them. All those have them. That all has them. Wonder where that unrouted ground is. Ah, right there. All right, everything is routed. So now we need to stitch up. We're going to stitch up our power planes. So same thing as before. This time I'm going to do it on the 5s. So 5 and 5. It's going to be 3, well, 3. There we go. Alright, stitched up pretty good. Pretty good. Put one next to these. Just gonna go look around where power 3 volt 3 is needed and make sure there's some pretty good stitching around it. That one's good. All right, I think look pretty good. Let's save, show our copper area, rebuild, and then real quick break. Okay, I'm back. Back. Okay, so we've got, the board is effectively done. We've got to do some labeling. And a couple other small design details, and then we're good. We got to order it, and I got to put the source up someplace so that you folks can play with it. So we're gonna do some. So let's grab some labels. So I'm just going to copy this because it's all sized. And this is going to be, I think I want to put it right here. Yeah, that's nice, right? So we're going to call this the GPS tracker. Maybe put it up on top or in the center. Do it here. GPS tracker V1A, which it is. And then I want to do something. I want to put a nice logo on there. Let's see if I have somewhere here a Wilderness Labs logo. Not on that one. This one probably has it. I made a. Well, that's the one. Also don't have it on that. I made a symbol, a footprint that is the Wilderness Labs logo. And it's pretty cool because it then shows up in gold on the, wait, I know I've got it on some things. Okay, let's just go find it. It's in the library. Wilderness. These two, medium, and let's see which one's gonna fit. All right, nice. Get that prefix, and I think that's probably where it's going to have to go. I don't see anywhere else it's going to fit. Be silly in there. You can put it in here. Oh, that's kind of nice, right? If we're going to do that, though, we're going to need to align this. Boop. Yeah, that's cool. I'll show you what that looks like. See? gold. Gold. Very nice. GPS tracker, V1A. Wilderness Labs logo. Looks pretty good. Actually, let's see what it looks like in our 3Ds. Doesn't look any different since last time, really. Awesome. Gosh. All right. Well, I think this board is done. Order to PCB, but let's see, top 1, 2, and bottom. Yeah, it looks pretty good. It was fun. You know, we covered a lot of things here. Layout, precedence, / ordering. We did some funky signals. We did some RF stuff here, and we stitched up. Oh, we did a 4-layer board. There's a lot of kind of advanced stuff that we covered here. Controlled impedance, but it was all pretty easy, right? You know, we just walked through and did it one by one. So I think this is done. I want to, I'm going to export this. Oh, it's not done. I've got to actually, one more thing. I've got to run the DRC errors to see if I've screwed anything up, which, all right. So solar 0.2. So I'm getting a bunch of track width errors, and let me see my design rules done. Yeah, so that was 2.5, so that should fix those. All right, clearance, trackpad. Okay, let's go fix these things. And this is why we run the DRC checker. Copper area and track. Do we need to like rebuild the copper area? Did we forget to do that? We. As if you guys have any fault in the matter. All right, look at that. Rebuilt the copper area. All those design rule check errors went away. So that's really good. We're looking fantastic. This is cool. So I'm gonna export this as an easy EDA, JSON. We'll call this V1A, PCB. I think that's just the PCB. Is it? I want to export. I want to see if I can. I want to export the whole project and save it to GitHub. I don't know if that's possible. Export. Let's go look. Let's go look at what that JSON file is. Yeah, what's that? Let's get this out of there. Garbage. Oops. Okay, JSON, there it is. Let's open it with text edit for now. Canvas shape. Yeah, that's just the PCB, isn't it? Boop, 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 boop. Yeah, there's a bunch of shape files, tracks. I don't see any like tracks. Interesting. Looks like my layers, DRC rules, some preferences, layer information, some vias. Yeah, this looks just like the some libraries. Yeah, this looks like just the PCB layout. Bummer. I was hoping I could just package the whole project up in into something that you guys could open. We can do this thing where we share it in the share on this OSH lab, but it's not very good. This is the open source hardware lab. It's kind of cool, but it's also, you have to go here instead of just to GitHub to find them, and it's kind of a kajanky experience to try to export and try to get it all right. However, with that said, you can just open them right in PCB, easy EDA PCB, which is kind of nice. So let me think on this. Let me think on how to open source this the best way. Probably what I'll do is I'll create a Git repo, and I'll put the design files in there, the schematic, and the JSON file, and then maybe also OSH hardware lab. Open source it, but I definitely want to open source this for you so that you can just open these and order this yourself or modify it for your own use. Cool. Well, thanks everyone for joining today. This was got done exactly what I wanted to get done. We took our schematic design, which we did last session, and we did a PCB design of that. Pretty exciting. We covered a lot of different concepts through this. Like I said, we did a multi-layer board. We did some RF, some radio frequency stuff. We did a little bit of high-speed signal routing with the USB, and we stitched some layers together. So it's kind of fun, right? And all pretty easy stuff that you could do. Definitely within everyone's skill set to do, as long as you have some some reference designs. You can just copy and paste from the schematics. It makes it pretty easy. Cool. All right. Well, folks, thank you very much, Trey. It's good to see you. It's good to see everyone else that came by, and I will see you next week. And I'm going to order this to PCB to fabrication. It won't be done until probably a couple of weeks from now. It's going to take a week and a half to get here, to get fabricated, and then get here, and then another maybe few days for us to assemble it. So we'll probably pick this particular project up and back up in 2-3 weeks, where we can start writing some software. So I'm not sure what we're going to do next week, but it'll be fun. All right. Adios, everyone.